Hi there. Let's take a look at a lab problem from section 2.1. In this particular question, we have an arrow that shot up on Mars with an initial speed of 61 meters per second. And then the height that's given in meters, that's t seconds after it was shot, is given by this equation. Y is equal to 61 times t minus 1.86 t squared. So they want us to find the average speed over the given time intervals between 1 and 2, 1 and 1.5, 1 and 1.1. So basically from 1 to some other point or other point in time, and then they want us to start decreasing that and getting closer and closer to 1. That's what looks like it's happening. So instead of doing that one by one, what we can do is we can approach it by finding out, letting this some value of h. And so this is what we have described here in our step 1. So the average speed between two times is given by the difference in the y values. So that's y of t2 minus y of t1 divided by the difference in the t values. So it's like the difference in y divided by the difference in x, except our independent variable here is t. So we're given that our y is this function, and that's y is equal to 61t minus 1.86 t squared. And we want to, since 1 is involved all the way through here, we want to evaluate when t is equal to 1. So let's put 1 into this equation when t is equal to 1. And we have 61 times 1 minus 1.86 times 1 squared, and that happens to be, according to them, it's 59.14. So now the average speed between the times when t is equal to 1 and t is equal to 1 plus some other number, the h can vary here depending on what your y value is, or depending on your next x value. The h can vary, but so what we're going to do is we're going to go from 1 to, instead of going from 1 to 2 and then 1 to 1.5 and 1 to 1.1, we're going to go from 1 to 1 plus h. So what we want to do is we want to put 1 plus h in for t into the original function, and then subtract y minus, or y of 1, and then the t value 1 plus h minus the t value here. So imagine that t2 is equal to 1 plus h. So we need to put 1 plus h in for t, and so it's going to be 61 times 1 plus h minus 1.86 times 1 plus h quantity squared. So this whole expression in the brackets is going to be y of 1 plus h. And then we have a minus, and we want to put y of 1. So y of 1, they calculated it for us as 59.14. The denominator, if we do this simple algebra, it's 1 plus h minus 1, so the 1's go away and we just have h in the bottom. Alright, so now here's some blanks that we have to fill in. It looks like we're concerned about the numerator, and it looks like the numerator will simplify to this something h over here. So let's see if we can work that out. Let's take a look at this expression. 61 times 1 plus h minus 1.86 times 1 plus h quantity squared, and that whole thing minus 59.4. So let's simplify that. How are we going to simplify that? Well, it looks like what we're going to need to do is we're going to need to distribute these things. The 61 will get distributed here. 61 times 1 is 61, and then 61 times h is 61h. So that part can be distributed here. And then now, before we can distribute the 1.86, we actually have to FOIL this out. So let's FOIL that out. So that's 1 plus h times 1 plus h. And remember, when you FOIL it out, you're going to get a middle term. So 1, the middle term is going to be 2 times 1 times h, and then the last term is going to be h squared. So this is the expression that we should be looking at. Okay? So now let's take a look at this expression, and now let's distribute this 1.86 times this. So I'm going to need 1.86 in times 1, 1.86 times 2, and then 1.86 times 1 again, and then we're going to multiply by h and h squared. So let's say that again. We got 1.86 times 1, that's 1.86. Well, actually we're multiplying a negative 1.86 times 2. I'm going to need to know what 1.86 times 2 is. That's 3.72. So this next term is going to be 3.72 times h. And then we have a plus, and then we're going to multiply by negative 1.86 times h squared. And there's no other calculator work for that. Alright, so this is what we have inside of the brackets. Everything is all foiled out, and now we just have terms. It looks like I would be interested in combining the constants. That would be a 61 times negative or plus, minus negative 1.86. And then we're going to combine it with this. So those are all the constant terms. Let's see, 61 minus 1.86, and then plus, well, we see the answer already here, 59.14. And so, oops, that's a minus. Let's start over again. That's 61 minus 1.86, and when I press minus, I see this 59.14, and I'm going to subtract 59.14, and then that's going to disappear to 0. So all these in yellow highlights go to 0. So let's change my highlighter color, and now this time I want to, what happened to my highlighter? I want to combine the terms with an h in it. So I have 61 minus 3.72. So it's 57.28h. And so if you notice, that's what they have over here, 57.28h. So let's go ahead and write that down. We have 57.28 times h, and then our last term is just this term, 1.86 h squared. And so if you're wondering why a lot of these things disappeared, it just simplified to this 1.86 h squared, and that's the number that we need to input for this block. Okay. Now the next line here is we need to factor out an h. So there's an h here and there's an h squared there. You can factor that h and h squared and cancel with the h in the denominator. And so all we will have left here is a constant 57.28, because the h that used to be attached got canceled with this h. And now we're going to have a minus 1.86 times h. And so this is only h because one of the h squareds here got canceled with this h, and so we are just left with an h. And so that's why this expression only has an h. So that's what they're asking for here. Let's submit it. And that looks good. Those are the answers that they were looking for. Alright, now let's step 2. Calculate the average speed in the time period between 1 and 2. So we have a general term for the average speed between 1 and 1 plus h. And so what we're going to do is, to find out what happens at 2, we're going to assume that this 1 plus h is equal to 2, which is to say that h is equal to 1. And we actually have that simplified term over here, 57.28 minus 1.86 times h. That's the expression that we got over here. And so that's the expression that we will use instead of starting from the original formula again. Notice if you start from the original formula again, you're going to do a bunch of division work. Here, all you're doing is putting the value in for h, and then we're getting nicer numbers. So it looks like we need to figure out what 57.2 minus 1.86 times 1 is. So that's just 57.2 minus 1.86, and then we got 55.34. So let's put that down. Similarly for this, now again we want to match up our second number, our second t-value, 1 plus h. We want to match that up to 1.5, and so we imagine that h is going to be 0.5, and so we need to figure out what 1.86 times 0.5 is. So 1.86 times 0.5 is 0.93. And then we want to do the subtraction. 57.28 minus 0.93, and we get 56.35. 56.35, and let's check that answer. Looks like we might have gotten this one wrong. Let's see. What was it again? 57.28 minus 1.86. 55.42. Wonder what happened. So 55.42. Let's try to submit again. Okay, so now it looks right. Step 3, now we go to 1.1. So remember, we're using this formula. It's kind of hard to see the formula, but let's see. This is the formula that we're using. Actually, this is the formula after we factor out an h. Remember that 1.1 has to be equivalent to 1 plus h. 1 plus h. So you would imagine that h is probably going to be 0.01 or 0.1, sorry. And so if that's h, then we have to figure this out. So let's put that in our calculators again. That would be 57.28 minus 1.86. And I'm using a scientific calculator, but it should follow the rules of the order of operations. So if I put a times 0.1 here, it'll know to do the multiplication first before the subtraction. So if I press enter or equals, I get a 57.0494. I guess if we want to 2 decimal places, then we go 0.09, and then that would be good enough. So let's backtrack and get rid of that and see what happens. Okay, looking good so far. And then the 0.01 is replacing the h with 0.01. And then let's punch this into our calculator and see. So what was it again? We've got a 57.28 minus 1.86 times 0.01, and we get a 57.2614. Round to do 2 decimal places. Let's go 0.26. And then we want the same thing here where we put in 0.001. So this is 0.01, this is 0.001. So 57.28 minus 1.86 times 0.001. Now, for those people who might be interested in using a program like Excel, or you can even write your programs in other computer languages, um, you might be able to save some time by just putting in the formulas, the functions that we're using, and then running it through. Anyways, we're doing it one by one. We're using a hand calculator, scientific calculator, and this is what we got. All right, so let's check our answer here. And it looks like it's all good. So if we take a look at the answers that we get for the slopes, starting from the 1.5, we get a 56.35, and then 57.09, 57.26, 57.28. You can see that it looks like it might be approaching to a specific value. So estimate the speed when t is equal to 1. Let's click here to begin. So as we let h get closer and closer to 0, it looks like it approaches something here when h approaches 0. Let's read it carefully. To estimate the speed when t is equal to 1, we need to estimate v average is equal to 57.28 minus 1.86 h when h approaches 0. This yields, we want to enter an exact number here. It looks like we can get 57.2628. 57.28 might work. They might want 57.29. Maybe, you know, if we take this and get a little closer, let's just go ahead and check. Instead of letting h be 0.001 like we did here, let's let h be 0.00001 or something. So 57.28 minus 1.86 times, and then 0.00001. And then we're going to get, again, close to 57.28. So it looks like it must be 57.28. If you're comfortable with limits, you're looking at the limit as h goes to 0 with this thing, and as h goes to 0, h will take this expression, or this term, 1.86, and make that go to 0, and then that all we would have left is 57.28. Alright, so to check that answer, we see that it's good, and now we've completed this problem. I hope that helps.